Ever since I got home, I've been working hard to get the studio set up for another year of videos. Today, I'm going to show you how I use 3D printing to upgrade my YouTube studio. Alright, let's get started with some printed organizers. It's no secret that I have a lot of stuff, and keeping it all organized, especially after a move, is a bit of a losing battle. I do have these drawers here on the wall, which back in the day were organized neatly and even labeled, but nowadays there's essentially a random assortment of parts in them. While I was in BC, I used leftover containers from kits to keep all of my hardware organized. This approach worked well, but I wanted to have quicker access to everything rather than needing to sort through a bunch of containers. As it turns out, a great solution already exists. This is Yell's Small Screw Organizer, a set of 20 small printed drawers that can hold basically whatever. Even better, there are spaces for standard 6x3mm magnets to press into the drawers so you can easily chain multiple units together. I printed 3 of these using the rest of my Matter 3D matte ABS on the Q1 Pro. As an aside, I found this filament has pretty poor layer adhesion, so I'm going to be using it for projects like this rather than for printer parts. Everything I printed at this point was basically stock, although I did opt to remove the Voron logo from the sides. I made a modded version with different size slots and drawers, which is helpful for holding larger hardware like pulleys, idlers, couplers, and more. I also designed a tray that magnetically attaches to the top of the drawers, that way you can also store things on top. Because everything is magnetic, I can rearrange the drawers at any time I need. Actually sorting through all of my stuff is still a bit of a work in progress, but I'm glad I finally have a system that works for me. All of my modded files are available on Printables, by the way. There's a link to those and all the other models in this video down in the description below. Before we continue, I'd like to thank the sponsor of today's video, PCB Way. They're known for high-quality PCB manufacturing and assembly, but that's only the tip of the iceberg. They also offer 3D printing, CNC machining, laser cutting, and even injection molding. Their quality and turnaround times are seriously impressive too. I've been using their services for the last 10 months, and it's great to have so many services available all in one place. Check out the link below to see everything PCB Way has to offer. And as always, thanks to them for supporting the channel. Next up, we're going to talk about audio. Over the summer, I had the pleasure of borrowing a Shure SM7B to record all of my voiceovers. While I loved the audio quality, I couldn't quite justify buying something that expensive just yet, so I had to get a little bit creative. This is the Shure SM58, another very popular microphone option. With a few printed parts, we can actually turn this mic into a budget-friendly SM7B. Okay, now obviously we aren't going to be changing the properties of the mic itself, this is more of a rehousing than anything else. DSLR Video Shooter released a video a few years ago where he mods his SM58, and the difference between that mic and the SM7B is basically indistinguishable. The best part is he released all of the STL files for free. Thanks, Caleb. Again, I printed these on the Q1 Pro with more matte ABS, and the result looks absolutely fantastic. Here you can see the main body and the grill, which thread together like so. To install everything, you first need to remove a screw from the microphone itself, then you can slide it into the main body and secure it in place with an M4x16 in the bottom. From there, we can remove the metal grill on the microphone like so, and replace it with the 3D printed grill from earlier. Finally, we attach the mount with 2 more M4x16 screws that thread into the plastic. I'm planning on using a 3/8" thread to mount the mic, so I have an adapter threaded into the mount already. I added a foam cover for the SM7B to complete the look, and we're done. While you can argue that this mod was a little bit unnecessary, I do like the added convenience of being able to mount the microphone to a standard thread. I bought a cheap stand to mount everything to, and after a quick debranding, that whole assembly now lives on my desk upstairs. As for the audio quality, well, you've been listening to it this whole time. I originally had 3 projects planned for this video, but unfortunately this last one didn't end up working out. I'm going to show it anyways, and if anything, you can take it as a lesson that not all things are worth DIYing. My goal was to make a camera monitor. I primarily shoot these videos on my Sony a7 III, and while it's a great camera, don't get me wrong, the screen on the back doesn't flip out, it only tilts up and down. This isn't a problem when I'm behind the camera, but for these videos, I'm usually filming myself doing things, and I have no idea if what I'm filming is actually usable or not. Now, admittedly, I've gotten a lot better at double checking this kind of thing, but early on I lost a lot of potentially really good footage just because I couldn't see what I was filming. This overhead shot from the Cappy build is over 20 minutes long, and it's all completely unusable because I forgot to refocus after moving the camera. This all could have been avoided if I could actually see the screen. Of course, I could buy a camera monitor instead, there are loads of those available online, but I wouldn't actually be making use of a lot of the features that those have. The only thing I need is just to see the screen from the front. I came across this video from AltCine about a DIY monitor, and I just had to try it for myself. The monitor makes use of this screen here, which can be purchased on AliExpress, as well as this driver board you see here. You will also need a hot shoe mount, some super glue, and all of the printed parts. As you can see here, the back plate had some pretty steep overhangs and bridging, which the Q1 Pro didn't handle very well. I probably should have printed this with supports. Full disclosure, these files aren't free like the rest of the models that I've showed, but they aren't expensive either. They're £5 or about $9.50 Canadian. Assembly is super easy. First, we just press the screen into the front. Once that's in, we can add the board holder on top and then slide the driver board into place. Attaching this ribbon cable here can be a bit tricky. I've plugged something into the driver board here just to make sure it stays properly aligned. Once we know everything's in place, we can sandwich it all together with the back plate. I let the glue dry for a few minutes, and finally we can thread the hot shoe mount into the hole at the bottom. This is really easy to do since the threads are already modeled into the part. Everything looked quite good, but unfortunately I wasn't able to get the screen to connect with the camera at all. I tried it on my second camera, the A7S II, as well, also to no avail. I'm absolutely not an expert here, but I think the issue is that the screen resolution is 800 by 480, whereas the A7 III seems to only output 1080p, 1080i, and 4K. I was hoping that with the HDMI output set to auto mode, it would sort of just figure itself out, but that unfortunately wasn't the case. I might revisit this concept later, but it's probably better to just cut my losses and go for an off-the-shelf solution instead. For anyone curious, it was $87.02 in total for the DIY monitor, and the cheapest ones available online were between $100 and $110. So yeah, cool concept, but probably not worth it. Well, there you have it folks, that's 2 ways I've used 3D printing to upgrade the studio. If you've seen something cool online and think that I should print it, definitely let me know in the comments. Thanks so much for watching, and stay tuned since I have a lot of fun projects coming up, especially since I finally fixed that hot end that I broke. I'll see you all in the next one.